Let us look at question number 10. You are given 20% weight per weight of KCl solution. So what does that mean? It means we have 20 gram of KCl, the solute, in 100 gram of solution. So what is the mass of solvent? It is 80 gram of water. The solution, of course, contain KCl with water. Right. Density is given to you in the question. Which, question A, you have to calculate the molarity of KCl solution. How can we calculate the molarity? You have to consider the mole of KCl divided by volume of solution in liter. How can we calculate the mole? Can we determine the mole? Yes, of course, since we are given the mass in gram. So, U divided by the molar mass of KCl here. The answer mole of KCl is 0.2681 mole. Then, next, how to determine the volume of solution? The volume of solution is determined from the density. So, you are given in the question, the density is 1.06 gram per mil. Right? Okay, so density of solution equals to mass of solution divided by volume of solution. Since the density given in the question is 1.06 gram per mil, which is here 1.06 gram per mil. What is the mass of solution? Mass of solution is 100 gram. Right? Then you insert it here. 100 gram, the mass of solution. Then of course you can calculate the volume of solution. So what is the volume of solution? And what is the unit? Must be in mil, of course, because you are given the density is in gram per mil. So you cancel off gram, and you have the final unit of mil. Right? So what to do with the mil? To convert into liter. Okay, then get back to the formula of molarity, which the concentration of KCl solution is, mole is 0.2681 mole. Then you divide by the volume of solution in liter. So what is the volume of solution in liter is 94.34 times 10 negative 3 liter. So what is the answer of molarity of KCl? Is 2.842 molar. This is the answer. Next, question B. Question B is asking you the molality of KCl. Molality. So we can go back to the definition of molality. Okay. So what is molality? Molality is you have to consider the mole of solute. So what is the solute is KCl. So mole of KCl divided by the mass of solvent water in kg. Right. Do we have the mole of KCl just now? Yes, which is 0.2681. So insert it here. 0.2681 mole divided by the mass of water in kg. Just now, what is the mass of water? The mass of solvent is 80 gram. So the mass of solvent is 80 gram. What to do with this 80 gram? To convert into kg. So 1, 2, 3. So it is 0.08 kg of solvent, the water. So insert it here. or 0.08 kg. Yeah? Then the answer is 3.35 mole per kg, or you can write it 3.35 m, the lowercase m, or you can write it the word molal. So this is the answer. Then next, question C. Question C is asking you to determine the mole fraction of KCl. The mole fraction of KCl. So the mole fraction of KCl, what is the symbol of mole fraction? So mole fraction is X KCl, which is equal to the mole of KCl divided by mole total. So what do we have for mole total is mole KCl plus mole water. Do we have the mole of KCl just now? Yes, which is 0.2681. You insert it here. Okay, masuk sini 0.2681 divided by 0.2681. What is the mole of water? Do we have the mole of water? No, not yet. We just have the mass. Right, so what to do with this 80 gram of water? Cari mole. Therefore, the mole of water is 80 gram divided by the molar mass of water. Okay, then you find the mole of water. Then you insert it here. You insert here. So answer, the mole fraction is 0.057. Put no unit. Mole fraction, remember, has no unit. Put no unit. Okay, next is okay, done. Number 10, A, B, and C. Okay, so this is C, the mole fraction. Question number 11. You are given 250 ml 2 molar of NaCl solution, density of the solution, which you have to determine the molality of the solution. So always get back to the definition. Molality is to consider the mole of solute. So what is the solute? Is NaCl divided by the mass of solvent in kg, which is mass of water in kg. Right. So how can you determine the molality? What do we have? We have the molarity of NaCl given and 250 ml. So what to do? Of course, you can calculate mole of NaCl equals to mv per 1000. So what is the molarity given? Is 2 molar times the volume is 250 ml, which you have to convert in liter. So divide by 1000. So the mole for NaCl is 0.5 mole. You insert it here. 0.5 mole. Then how to find the mass of water in kg? Okay. What else given? The density. Right? What is the density? Density for the solution is mass of solution divided by the volume of solution. You are given the density of the solution is 1.077 gram per ml. Right? What else given? The volume. Volume given is 250 ml in the question. So can you calculate the mass of solution? Yes, of course you can calculate the mass of solution. Why you have to find the mass of solution first? Because we know that total mass of solution is equal to mass of the solute. What is the solute just now is NaCl, mass of NaCl plus mass of water, right? Okay, so what is the mass of solution? You insert it here. Okay, you insert it here. So mass of solution 269.25 gram. How about the mass of NaCl? Do we have the mass of NaCl? Not yet, but do we have the mole of NaCl? Yes. So what to do with this 0.5 mole is to convert into the mass in gram first. So how can we convert the mole of NaCl to the mass in gram before you insert it here? So what to do is 0.5 mole of NaCl, okay, mass of NaCl equals to 0.5 mole of NaCl times the molar mass of NaCl, which is 58.5. So 0.5 mole of NaCl times with the molar mass of NaCl, which is 58.5 gram per mole. So answer is 29.25 gram. That is your mass of NaCl. You insert it here, 29.25 gram, right? So of course you can calculate the mass of water. So what is the mass of water? It will be here. Okay, then you calculate the mass of water, mass of your solvent. Okay, then what to do next is to make sure you convert into how many kg? Why we have to convert into kg? Because the molality must consider the mass of water in kg here. Okay, so what is the answer? Question A, the answer is 2.083 mole per kg, or the lowercase m, atau the word molal. Okay, so this is the answer for 11A. How about 11B? 11B is to calculate the mole fraction of NaCl. Mole fraction of NaCl. So what is the symbol? Is X. NaCl equals to mole of NaCl divided by mole total. And NaCl plus and water. What is mole of NaCl just now? Mole of NaCl is 0.5 mole. Insert it here, 0.5 mole divided by 0.5 mole plus mole water. How about mole water? Do we have mole water? Not yet. So what to do? From the mass of water here, okay, so from the mass of water here, you find the mole of water. You find the mole of water, then you insert it here. So mole of water is 13.33. The mole of water is 13.33 mole. Okay. And the final answer, mole fraction of NaCl, is 0.036. Remember to put no unit for mole fraction. Remember, mole fraction has no unit. Okay, next. Question number 12. Question number 12. The density of 95% by mass of sulfuric acid given. Here. See, 95% of sulfuric acid by mass means it is a very concentrated sulfuric acid. Which 12A, you have to find the molarity of sulfuric acid. So how can we find the molarity of sulfuric acid? Get back to the definition. Molarity must have the mole of solute, which is sulfuric acid, divided by the volume of solution in liter. Right. Okay, what does that mean by 95% by mass of sulfuric acid? Means you have to assume that 95% by mass of sulfuric acid is equal to 95%, 95 gram of sulfuric acid in 5 gram of water only. Total made up of 100 gram of solution. So what do we have in the solution? Of course, sulfuric acid plus water. Right. Okay. Question is asking you to calculate the molarity. Right. Since you have the mass is 95 gram, of course you can determine the mole of sulfuric acid. How about the volume? The volume is what? We have to use the data from the density given is 1.84. We know that the density of the solution equals to the mass of solution divided by volume of solution. So the density given just now is 1.84 gram per mil. The mass of solution is 100 gram. Then of course you can calculate the volume of solution. Once you have done the volume of solution in mil, because the the density of solution given is in mil, so you can cancel off gram, then you have the final value of mil. Then what to do is to convert into liter, then get back to insert it in the formula here. Answer A, question number 12A, the answer is 17.82 molar. Okay. Next, 12B. The volume of acid needed to prepare 1 liter of 0.08 molar. Volume of acid needed to prepare 1 liter of 0.08 molar. So, when we refer to the initial concentration is 17.82. This is a very concentrated acid. This is a very concentrated acid, 17.82. Which this is your stock solution of sulfuric acid. Now is to dilute the acid into this concentration of 0.08. Not even 1 molar pun. Tak sampai pun 1 molar. Sangatlah cair. On the 0.08 molar. So from this concentrated acid, you have to prepare the dilute one, which is 0.08 molar. Okay, next is to write M1 V1 M2 V2. Okay. For question B, M1 V1 equals to M2 V2. Means the mole before the dilution is the same after the dilution. So this is before dilution. The mole before dilution equals to after dilution. What is the molarity of the stock solution just now? The molarity of the stock solution just now is 17.82. Tersangatlah pekatnya 17.82. So write it here, 17.82. What is the volume? That is, you have to find the volume of acid needed to prepare. So, you nak ambil berapa from the stock solution in order to prepare this 1 liter of 0.08 molar of solution, the dilute kan. So, before dilution, sangat pekat. After the dilution is to, to prepare only 0.08 molar. So, that is your M2. Volume is to prepare 1 liter only. Of course, you can calculate your V1. So, what is your V1? The answer, question 12, is 4.487 mil. That's all for question tutorial until number 12. Thank you.